Imagine a cosmic cannonball, fired by our own sun, poised to intercept an object that has traveled from galaxy to galaxy, oblivious to the internal dynamics of our system. This is not science fiction, but rather the dramatic scenario that recently unfolded involving Comet 3I/Atlas, the third interstellar object ever detected in our neighborhood. We are talking about an event of immense rarity, as for the first time, scientists had the expectation, and fear, of witnessing a plasma shot ejected by our star colliding with an outside visitor. Such a collision, if it occurred, would not only tear the comet apart but also provide invaluable data on how these strange celestial bodies react to intense solar forces, something we have never had the opportunity to investigate. The scientific world held its breath, waiting to see if this cosmic outsider would be caught in an explosive embrace of magnetic fields and charged particles. Atlas was in imminent danger. Intense outflows of material ejected by the sun, often called solar wind or plasma bursts, constantly interact with objects orbiting our planet. Not long ago, for example, Comet Swan, C/2025 R2, nearly had its impressive tail shredded and disconnected by one of these bursts, a somewhat routine occurrence for comets residing in our solar system. This disconnection, called a fragmentation event, is known and documented, but in each of these cases, the object struck was always indigenous, created and shaped by the radiation and materials present in the Oort cloud and Kuiper belt. This distinction is crucial, as an interstellar body like 3I/Atlas, formed in another region of the Milky Way, may have a radically different composition, structure, or strength. Therefore, predicting what would happen if it were struck by a coronal mass ejection, CM, was, until now, a theoretical mystery, which elevated the potential incident to an unprecedented scientific opportunity. The reason for the alarm was a warning issued by a NASA prediction model, which identified an almost guaranteed collision trajectory. On September 19, the Sun unleashed a powerful coronal mass ejection, or CME. A CME is, simply put, a gigantic jet of superheated plasma and magnetic fields released by violent eruptions on the solar surface. This material travels through space at high speed and was predicted to cross the orbital path of Comet 3I/Atlas between September 24 and 25. The collision of a CME with a native comet typically destabilizes it and sometimes fragments it or rips off its ion tail, drastically transforming its appearance. Astronomers on duty hoped that the impending impact would provide the first real opportunity to investigate, in real time, the dynamic effects of these interactions on genuinely foreign material, capturing data on the density, structural stability, and reaction of the comet's nucleus amidst the solar chaos. The predicted interception deadline has come and gone, plunging the scientific community into frustrating uncertainty. Strangely, no official, definitive confirmation has yet emerged, either from NASA, NOAA, the U.S. National Oceanic and Atmospheric Administration, or solar observatories, indicating that the CME actually collided with 3I/Atlas. This suggests that the interstellar visitor may have miraculously narrowly avoided the violent blast of solar plasma. However, the lack of confirmation is not the same as proof that it did. Some international news outlets have speculated that the impact may have occurred, albeit subtly or as yet undetected, while the comet was hurtling toward Mars at an impressive 219,000 km per hour, 134,000 miles per hour. The high speed and complexity of monitoring objects in this region of space, coupled with the rapidity with which it is approaching the Sun, contribute to the difficulty of issuing an official verdict. The scientific urgency surrounding this comet is amplified by its extreme rarity. In the entire history of astronomical observation, only 3 objects originating from outside our solar system have been confirmed: the cigar-shaped asteroid Oumuamua, discovered in 2017, Comet Borisov, detected in 2019, and, finally, Comet 3I/Atlas, sighted in July of this year. None of these three illustrious visitors was the target of a CME during its passage, making a possible incident with Atlas a chance science would never have again in the near future. This opportunity was doubly urgent because Atlas is about to disappear from our terrestrial view. In a matter of weeks, it will be on the other side of the Sun, beginning in October, as it approaches its closest solar approach, called perihelion, predicted for the end of the month. Collecting data now is crucial, before it plunges back into the dark depths of interstellar space. Parallel to the CME threat, Comet 3I/Atlas exhibited fascinating and unprecedented luminous behavior that demanded the immediate attention of astronomers. Since early September, the comet's brightness has increased colossally, about 40 times more intense. To contextualize the magnitude of this change, the comet went from an apparent magnitude of 16 to 12. On the astronomical scale, the lower the number, the brighter the object. To be visible to the naked eye in dark skies, it would need to be below magnitude 6. The dramatic change in magnitude 4, captured in iconic images by renowned amateur astrophotographers such as Gerald Riemann and Michael Yeager, confirmed the sudden increase in activity. This phenomenon indicates a violent and accelerated release of gases and ices that were frozen within its interior, demonstrating that Atlas is awakening much more energetically than expected. The increase in brightness not only intensified its overall light but also revealed clues about the chemical composition of this alien body. Spaceweather.com, a website specializing in space weather, highlighted that the comet's glow is predominantly green. This characteristic coloration has a fascinating scientific explanation. As Atlas approaches intense solar radiation, it begins to release diatomic carbon. This specific gas glows intensely fluorescent green when bombarded by ultraviolet sunlight. Studying this glow helps scientists understand the type of interstellar material it carries. Returning to the central point, the lack of reports of fragmentation, visible disturbance, or debris detection means that, despite predictions, all evidence points to 3I/Atlas not being destabilized by the CME. The absence of fragments suggests a clean and safe escape from the plasma blast. Study of the comet has not been limited to the solar threat alone, but has also expanded to understanding its size and mass. Measuring a comet's mass is an extraordinarily complex task. Unlike planets and moons, where scientists can use the motion of their natural satellites to calculate gravitational pull and, consequently, mass, a comet offers no such assistance. For 3I/Atlas, the methodology required analyzing thousands of detailed observations made by more than 200 different telescopes between May and September. Astronomers had to carefully compare the comet's exact trajectory through space with the theoretical path it should have taken if only the Sun's gravity were affecting it. Any deviation is a signature of material escape, allowing them to estimate the rate of mass loss and thus reverse the calculations to determine the nucleus's original size and total mass. The results of these complex analyses and comparisons shocked the community. Comet 3I/Atlas is not just a rare interstellar visitor, it appears to be a giant. Estimates indicate that its solid nucleus is at least 5 kilometers in diameter and carries a mass exceeding 33 billion tons. For most comets, these numbers are astronomical. Typical solar system comets typically have nuclei measuring less than 1 or 2 kilometers. These data raise the monumental question: is 3I/Atlas the most massive comet ever to cross our system? Whether it's the largest or just one of the big ones, the fact remains that it represents an unparalleled window into the distant past of another star system. As it continues its speeding path toward the Sun and prepares for its final escape, the scientific community celebrates the likely escape of this 33 billion-ton treasure, which narrowly avoided being swallowed or destroyed by a plasma blast from our star. The study of 3I/Atlas is just beginning.